Hello, hi everyone, good afternoon. My name is Dr. Akash and today we are going to learn about Newton's first law of motion. So here we're going to start. Till now we have learned about the equations of motion. So in that the object can change the speed. But do you know what causes that change? It is this force. And we are going to learn these laws. So there are three laws given by Newton. So they will tell you how the forces they act on different objects. So that is the purpose of this chapter. Alright, good afternoon everyone. Shubham, Samar Pita, Radhe Sham, welcome all. So if you are meeting me for the first time, this is about me. I have PhD from National University of Singapore, BSMS dual degree from IISER Pune and ranked in JEE Advanced. Alright, hi Real Abhimanyu Ansh Patel, Priyanka Kumari, hi everyone. Let's start. So now, do you know what is the state of motion? Did you know about this? Have you heard about this? Good afternoon. Hello Power Topics. You're from Malaysia. Nice. Nice to have you here. So what is state of motion? So let's understand that. So for example, do you see these images? In the first one, what is happening? This boy is kicking this football, right? In the second one, this person is catching the tennis ball. In the third one, there is a ball coming towards this batsman. He is hitting the ball in different direction. So what is happening here? Hi Bimla Kumari, good afternoon. So here these different objects, they have different speed and they have a particular direction. That means they have a velocity in different direction. So what is the state of motion? So the state of motion is nothing but whether the object is at rest or if it is moving. That means does the object have any speed, and if the object have any speed, is it moving along any particular direction? So that is the state of motion. So state of motion is, you can write what is the state of motion. It can be the velocity of the object or the object is at rest. So if you want to change, so this is called as state of motion, state of rest or state of motion in a straight line. So how will you change the state of motion of the object? So for example, the object is at rest. This football was at rest. If you kick the football, what happens? The ball will start moving. That means you are changing the state of motion of the object. Or in this case, the ball was coming towards this boy. So initially, this ball has some speed, some velocity. When you catch it, what happened? The speed decreased. So when you increase or decrease the speed, that time we can say we are changing the state of motion of the object. Or, so there are these things, you can either increase or decrease the speed, increase the speed or decrease the speed, or you can change the direction. For example, the speed is not, you are not changing the speed. If let's suppose there is an object here, it is moving in this direction with a velocity of 2 meters per second. After some time, what happened? This object started moving in this direction with the speed of 2 meters per second. But in that case, what happened? The direction has changed. And is it possible? Do you think it is like possible if the object is going in a straight line, it will automatically by itself change the direction? Is that possible? No, it is never going to happen. Why? Because if you want to change the direction of the object, there must be some external force. If you apply that external force, then only the object can change the direction. Even here, if you want to increase or decrease the speed, the object cannot decide by itself whether to increase or decrease the speed. But what it can do? So we can apply the external force and that external force can increase or decrease the speed. So how do you change state of motion? We can change the state of motion of the object only by applying the external force. Is that clear? Frame of reference, yes, we'll come to that. Hi, MA Science, something with me. Solve this question, everyone. So question is, which of the following statements are true? Multiple correct. Choose all the correct options. So what do you see here? This person is playing with the ball. Now just look at, observe the motion of the ball. Here it is like up and down, then ball came here and came down and finally set to the rest. Just look at how the ball is moving through that basket. So which one do you think is correct? Sorry. Which of the options is correct? First option, there is a change in the state of motion. Is that correct? Yes, that is correct. Why it is correct? You see the direction of the movement of the ball. So ball is like up and down, then going this direction, coming down. So there is a change in the direction. So there must be a change in the state of motion. That is correct. How about next one? The speed of the ball is same. Do you think it is same? No. You see, finally ball is coming to the rest. Here at this point, it is coming to the rest. So is the speed same? No, speed is not same. So that is not correct. How third one? Direction of motion is changing. Yes, this is correct. Direction of the motion is changing. You see these arrows? So it will tell you the direction of motion is changing. There is no force. That is not correct. If there is no force, ball cannot move by itself. We need to apply the external force. Finally, going to take a drop from 5th floor. Don't do that. Screenshot is not clear. Okay, never mind. It's there's a GIF file. If it is not clear, it's okay. You can watch it later. It needs a better internet quality to see the GIF files. If it is not clear, it's okay. Now let's learn what is the first law of motion. So there is a statement given by the Newton. So it says the object maintains state of rest or uniform motion in a straight line until and unless unbalanced or external force acts on it. So what does it say? If, let's suppose, the external force is 0, if external force is 0, that means the initial velocity should be equal to the final velocity. Okay, I'll dissect it down. So state of rest, object maintains state of rest. So if object is at rest, initially at rest, then it will continue to be at rest. If the object is at rest, it will continue to be at rest. So for example, if let's suppose there is a table, on this table there is a book in your house, and let's suppose you place the book and you left, like you went somewhere for a vacation, holiday, you came back after 1 week, and within that time period, nobody came into your house, nothing happened. Your house is as it is. Will this book move its position? What do you think? All the doors, windows, everything is closed. Can the book move from its position? No, that is correct. Book cannot itself move from its position. So if the book is at rest, it will continue to be at rest. For example, now I'll give you another example. if you are in the outer space, away from the earth, away from the sun, so there is no gravity. Just assume that you are much far from all the planets and stars. Now you have some object in your hand, you throw that object. So can this object move in a straight line, and will it travel with the same velocity, same speed? What do you think? You are away from all the different like planets, stars, away from everything. So answer is yes, the planet will move with the same speed or same direction. So the velocity of the planet will not change. No gravity, right? So that is even easier. It cannot change the direction if it is moving. Do you watch sci-fi movies? So if you are in the outer space, there is no gravity. That means there is no external force. So the external force is zero. If the external force is zero, that means no gravity. Gravity is a very big force, right? Gravitation. So if there is no external force and you are at some region where there is no gravity, now if you throw the object, what will happen? Object will continue to move in a straight line. It cannot change its path, and it cannot also change its speed. So that means its initial and final velocity will always be equal. We'll learn the third law, not now, Bharat. We'll learn the third law after some time. That time I'll explain you. Come back again. So that is the Newton's first law. So in general, so I'll tell you one more quantity, physical quantity, then okay, maybe inertia. You know what is inertia? We'll come back to the first law again after I explain you the inertia. Do you know what is inertia? In simple terms, like in layman's terms, inertia is the laziness. What is inertia? It is the laziness. So what is laziness? For example, it is a Sunday morning, nice, you are sleeping nicely at your home, and suddenly your mom or your father start waking you up. Do you feel like getting up? Like your cat, okay? Do you feel like getting up in the Sunday morning at 6 a.m. in the morning? No, right? You don't feel like getting up. All the objects in the universe, they are as lazy as you and me. Even I don't feel like getting up. So all the objects in the universe, they are very lazy. And in scientific terms, that laziness is called as inertia. Inertia is like a resistance. So whatever we are doing, we want to keep that doing forever. We don't want to change it. That is the inertia. Understood? What is inertia? So this is a definition. Inertia, it is a tendency, that means a property of the object to resist change in the state of rest or state of motion. This is called as inertia. So if the object is at rest, the object want to continue to be at rest. No matter what happens, object want to just sit there. If the object is moving, object want to move with the same speed. It does not want to increase or decrease the speed, and it will want to move in a straight line. It does not want to change the direction. That is called as inertia. Clear? And how do you change the inertia if the object is moving in a straight line, but after some time, let's suppose here this object, if you roll the ball on the floor, what will happen? Ball will move certain distance. After that, ball is going to stop. So why the ball is going to stop? It is because of the friction. All the surfaces in the universe, if it is a surface, that means there would be some friction. So if there is a surface, no matter how smooth the surface is, it will still have some roughness, and because of that it will provide the friction. So if there is an object here, object is moving in this direction, so there is a friction, and friction will oppose. So friction is in the opposite direction, opposite to the motion. And what this friction will does? Friction will make sure that this object is going to stop. So object will move certain distance, and after that it will come to rest. Clear? Why the object is stopping? Because of the friction. In outer space there is no friction, or if you on earth, if you can prepare a completely frictionless surface, that is not possible, but we can go towards that very smooth surface. Then if you reduce the friction, you will see that this object is very difficult to stop, right? If you put a soap water on the marble floor, and if you try to walk, can you walk? It is very difficult. Why? Because the surface is so smooth, there is almost no friction. Okay? Yes, friction opposes the motion. So again I am repeating, what is the inertia? It is a tendency to resist the change, in the state of rest or state of motion. So if the object is at rest, object want to be at rest forever. If the object is moving, the object want to move forever, but there are external forces like friction. So these external forces like if your father or your mother comes in the morning to wake you up, that is the external force, not in your control, correct? So this friction is not in control of the object. You are the object. Your parents, they are the force, external force. So they change the motion, they oppose your inertia, they oppose your laziness. Clear, right? Alright, do you play this game, carom? Amount of force? Yeah, we'll learn about the force in the next class, not now. Inertia depends on which factors? Okay, I'll come to that. We'll discuss this today. How rockets are programmed to stop. So rockets are very complicated right now to discuss. They have lot of different factors which affect the motion of the rocket. It is not a single object which is moving. Alright, so this is a very simple game which is called as carom. So here there is a striker, and let's suppose there is a striker. If you hit the bottom coin, hit very hard, only the bottom coin, what will happen? Can somebody tell me? So let's suppose I'll draw here, there are different coins placed on the top of each other, and there is a surface, there is a carom. On the carom board, these are the different coins placed on the top of each other. Now what we do is, we hit the bottom coin with a striker. So when you hit the bottom coin, what will happen? So this bottom coin, it will move. This bottom coin will move. It will come out. It will come out. Now these coins, they are hanging in the air. So if they are hanging in the air, what will happen? Can they hang in the air forever? No. So why they are first of all hanging in the air? It is due to inertia. Inertia of rest. These coins are at rest. So they want to be at rest forever. But now there is no support, and because of that they will fall down. Okay? You want to see the animation? You can do this experiment at your home. I'll come to this. So look at this animation here. So there is a cardboard. You flick the cardboard. What happens? There is a 5 rupees coin. Once you flick the cardboard flies away, and this coin, it drops into the beaker. You can do this experiment at your home. take a cardboard, very flat and very smooth cardboard, place a coin on the top of it, then flick this cardboard, flick it away. So what will happen? The cardboard will move away, but now this coin is hanging in the air. So it will look something like this. There is a beaker, and on this beaker there is a coin here which is hanging in the air. Cardboard has already came out. So now this coin, there will be a gravity. So gravity will pull the coin and coin will fall into the beaker, right? As shown in this diagram. So what is this? This is called as inertia of rest. So the object, which is the object? It is this coin. Coin is at rest. So coin want to maintain its state of rest. Coin want to maintain its state of rest. So it will try to stay here until and unless there is an external force. But once there is no support, so now there is an external force which is the gravity. So gravity will pull this coin into the beaker. Correct? Yes, nice. So what is inertia of rest? It is a tendency of the object to resist the change in the state of rest. Object want to be lazy. Object want to be at rest forever. That is the inertia of rest. Clear? Some other examples. Dusting a mat, shaking the branches. Have you tried this, dusting a mat? You can do it at your home. So what you do is, let's suppose if there is some dirty, there should not be mud, but dirt. Like let's suppose there is a mat, and on the mat there are a lot of particles, dust particles. Now what you do is, using some some metal or something, you hit the bottom of this mat. So what will happen? If you hit, mat will go behind. Mat will be pushed behind, but the dust particles, they will remain at rest. So when you look at it from a different angle or from a distance, it will appear that when you hit the mat, the dust particles are coming out. And why that is possible? Again, because of inertia of rest. Clear? Swing. We'll come to swing. So now what is inertia of motion? So here, let's suppose you are inside the car and suddenly the driver applies the brake. If the driver apply the brake suddenly, what happens? You will get a jerk in the forward direction. You will be pushed forward, right? Why you are pushed forward? Because you are inside the car is moving with some speed, and suddenly driver apply the brake. Now what happens? The car will come to rest, but our body is still moving. Our body is moving in the forward direction, and that is why we get a jerk in the forward direction. This is called as inertia of motion. So the object will want to continue to be in the state of motion. Objects, they are lazy. They don't want to change the state of motion. You see this animation? Here this person who is on the truck suddenly stops. But the person, he has a speed, so it will fall down. Correct? That is the inertia of motion. Another example, moving a fan, moving top. So in your house, if you have a fan, turn on the fan, put it at a maximum speed, and now switch it off. What will happen? Will the fan stop immediately? No. Fan will move, fan will rotate for some time, and then it will stop. Why it cannot stop immediately? Because fan has the inertia of motion, right? It will continue to move for some time, then it will come to the rest. Why will it come to the rest? Again, because it is moving. There is a friction between the fan and the ceiling, or between the different components of the fan. Because of the friction, fan will stop. Okay? Third one, it is inertia of direction. So let's suppose again you are inside the car. Let's suppose there is a car here. Car is moving in this direction with a speed v. So there is an object. There is an object which is loosely placed in the car. Let's suppose there is a water bottle or something, or you are sitting in the car and suddenly car takes a sharp turn. So car now moving in this direction. Car is moving in this direction. Car takes a sharp turn. Now what will happen? This object is also moving in this direction, right? So it will continue to move in a straight line, and because of that the object will come to this side. It will get a push in the sideways. So when the car takes a sharp turn, do you feel that you move sideways? If the car turns to the left, we move towards the right. If the car moves towards the right, we get pushed towards the left. Why that happens? It is due to inertia of direction. So all the objects, they want to continue to move in a straight line, but the world, the car doesn't allow. They will force us to move in different direction. They will force us to change the path, right? But we will resist, and that resistance is nothing but inertia of direction. Clear? Easy, right? Now, do all bodies have same inertia? What do you think? Do all the bodies in the world, do they have same inertia? Obviously no, right? Some people are more lazy, some are not that lazy. So how do you determine who is more lazy, who is less lazy? So in scientific term, different objects, they have different mass. So the mass will tell how much inertia the object has. Greater the mass, greater would be the inertia. Right? Yes, correct. Greater the mass, greater the inertia. So mass is a measure of inertia. If the mass is greater, for example, elephant is much bulkier, much heavier. So mass is more. So if the elephant start running, it would be very difficult to stop the elephant, right? But if let's suppose a rabbit is moving, so rabbit can stop very quickly. Rabbit can change the direction very quickly. Yes, but if the elephant is moving with the same speed, it is very difficult for the elephant to stop. Elephant will crash to some building, it will damage the trees. It is very difficult to stop. Why? Because elephant has more mass, so very high inertia. Clear? Yes, ants, they can change the direction anytime. Greater the mass, greater is the inertia of the body, and vice versa. Less the mass, less would be the inertia. Now solve this question. So which of the following quantities will have maximum inertia? Out of these four, which one will have the maximum inertia? Is it the motorbike, car, truck and train? Yes, absolutely correct. Answer is train. Train is very bulky, more mass, huge mass. That is why it is very difficult for the train to stop. Recently there was an accident, right? Near Orissa. Why these accidents can happen and why they are very devastating? Because train is bulky, it is huge. So train has very high mass. Because of that, even if the train has a little bit speed, little bit velocity, it is very difficult for the train to stop. If it is a car, car can stop very easily. But if it is a heavy object, then very difficult to stop because it has very high inertia. Out of these four, train has the maximum inertia. Now choose this, choose the wrong statement. So statement 1, inertia is a property of the body to be at rest, property of the body to be in motion, property of the body to be moving in a straight line, and last, measured in kilograms. So option number 1, that is correct. Inertia is a property of the body to be at rest, that is inertia of rest. Option number 2, inertia is a property of the body to be in motion, that is, I'll write down here, this is inertia of rest, inertia of rest. This one is inertia of motion. Second one, inertia is a property of the body to be moving in a straight line, that is inertia of direction. So all these three, they are correct. How about the last one? This is wrong. This statement is wrong. Why it is wrong? Can somebody tell me? What I told you, inertia is the, mass is a measure of inertia. But did I tell you mass is equal to inertia? No, mass is not equal to inertia. Mass is proportional to the inertia. Or we can say inertia is proportional to the mass. I never said inertia is equal to the mass. Mass is only measure of the inertia. Okay? So that is the reason this statement is wrong. We don't measure the inertia. We cannot measure the inertia, but there are other physical quantities such as momentum or moment of inertia. We'll learn that later. So those properties we can measure. Inertia we cannot measure. Clear? So that's it for today. This is a Telegram channel. Go to this Telegram channel. You can find all the details like all the notes, lot of questions, MCQs, PYQs in this Telegram channel. So thank you so much. If you have any questions, any doubts, you can either comment here or you can comment in the Telegram channel. So I'll be there in the Telegram channel. If I find out your doubts, I can answer, or you can just comment at the end of the session, right? You can type your comments. I'll try to answer. All right, everyone. Bye-bye. Where can you find the other sessions? This is a Infinity Learn channel. Go to the Infinity Learn channel. There are live classes. Go to the live class session. So there are other classes. So we can learn that. Next class, I don't really know when is the next class, but we'll see. So right now we are like quite busy, all the faculties. So we don't have much time. We are trying to have at least one class for 9th and one class for 10th on YouTube. Okay. Third law is true, then beat us with the hands. Why does the teacher doesn't feel the same? Teacher does feel the same pain, just that this palm and this is a skin. I mean, there's a face. So if the teacher slap you on the face, then this skin on the face is more sensitive. This palm, here the sensation is lower. So teacher will get a less sensation. Why? Because the neurons which are present on your palm are much less compared to the neurons which are present on your face. Okay? So that is why if somebody slap you, you will get a more sensation because there are a lot of neurons present on the face. On the hands, there are not that many neurons. So this palm is like a very robust. It does not feel that much sensation. Is there a playlist? Yes, for grade 9, there are two batches, Pratham and Pioneer. Pratham is for grade 9. So there is a playlist for Pratham batch. Pratham is for grade 9. Pioneer is for grade 10. Alright everyone, bye bye. Take care. Enjoy.